Okay, section 2.1 is on page 76, solving linear equations. A linear equation is, in one variable, is an equation that looks like this, in where that letter A and that letter B represent real numbers. They could be any number. Now, an equation means that there's an equal involved. That's what an equation is. In math, we have two types of problems. We have expressions and we have equations. So, in an equation, you have two values that are equal. Expression, you have a combinations of numbers and variables. Separated by a plus or minus. So, you simplify an expression, you end up with an expression. An equation has the equal. You're setting the two expressions equal to each other. You're trying to solve. And most of the time you end up with a solution. Linear means the power on the variables equal to exactly 1. No two variables are multiplied or divided. And that's what this section is about. So, to solve a linear equation, like 1 through 14, solve the following linear equation. What you do, you get rid of parentheses, you combine like terms, and you move the variable to one side and the numbers to the other side by reversing order of operations. I'm looking on page 82, number 2. I'm looking at this and I'm thinking, okay, well, I see this side is already simplified, this side is already simplified. It is a good habit to get into to move the smaller variable to the larger variable, meaning I'm going to move the 3z to the right since 6z is bigger. And when I move it to the right, that means I'm subtracting 3z. So if I subtract 3z from both sides, 6z minus 3z will be 3z. And once I have the variable on one side, I reverse order of operations. That is, I look at everything that's being added or subtracted. 17 is being subtracted. I add 17 to both sides. 3z will equal negative 4 plus 17 is 13. And the 3 is being multiplied by z. To reverse that, to undo that, I divide both sides by 3. And z will equal 13 over 3. And that would be my answer. You don't have to write this in a mixed number. It's fine. You don't have to write it in a decimal. Number 6 is the next problem on the list. In this case, I see that there are parentheses. I get rid of parentheses by using the distributive property. This 7 is multiplied by everything inside of that parentheses. 7 times 4 is 28. And 7 times negative 3z is minus 21z. The plus 3 I just copy down. And the same process on the second side of the equation. Negative 6 times z is negative 6z. And negative 6 times negative 4 is positive 24. I copy the negative 8 down. Now I combine like terms. Negative 21 is one of a kind on the left-hand side of the equation. 28 plus 9 is 30. 28 plus 3 is 31. On the right-hand side, negative 6z I leave alone. Those two are like terms. 24 minus 8 is a positive 16. And now I move, again, it's a good habit to move the smaller variable to the larger variable. I add 21z to both sides. Negative 6z plus 21 is 15z. Copy everything else down. And now, to get z by itself, I reverse order of operations. 16 being added, I subtract that from both sides. 31 minus 16 is 15. And to get z by itself, I divide by 15 both sides. And I get z to equal a 1. So 1 is the solution of this equation, meaning if I replace z by 1 on both sides, the left side and the right side will be equal. Something that we're never going to get rid of is fractions. There are a couple of ways you could solve this. I want you to get into the habit of finding LCD. That's going to save you a lot of pain on the long run. The LCD for this problem is 36. Now, we only have expressions versus equations. The process of simplifying those is the same. You want to make sure all the terms have the same denominator. Now, it's true, you could simplify. You could reduce, divide by 3, make that a 3 if you wish. That will save you a bit of time. And now you would say, well, look, this problem is really 7 minus 2x over 4 equal x plus 5 over 3. And now you could say the LCD is 12. If you were to use 36 and not simplify, you'll get the same answer. However, when you're going to simplify, the numbers are going to be bigger. Now, in math, I am allowed to multiply by 1. A times 1 equals 1 times A equals an A. So anytime you want to multiply, you're allowed to multiply by 1 or add a 0 if you wish. A plus 0 is 0 plus A, which is A. So in multiplication, you could multiply by 1 because that doesn't change a value. And in addition, you're allowed to add a 0. And these are the two main rules that we have to be careful with. So my goal now is to make both of these fractions over 12. What do you multiply 4 with to make it a 12? A 3. And since you can only multiply by 1, 3 over 3 is a 1. You want to make sure that that's always a 1 what you're multiplying with. And when I look at the right side, I say, okay, there's a 3 there. What do you multiply a 3 with to get a 12? A 4. Again, since I'm only allowed to multiply by 1, I want to make sure that any number over itself is a 1 except for 0. The beauty of equations. If this was an expression, I would have put the entire answer over 12. But if it's an equation, you ignore the denominator completely. So this problem just became 3 into 7 minus 2x and a 4 into x plus 5. And that's how we get rid of fractions in every section of this book. And now we use the distributive property. 3 times 7 is 21. 3 times negative 2x is a minus 6x. 4 times x is 4x, and 4 times 5 is 20. I'm going to move the smaller variable to the bigger variable. Add 6x to both sides. That becomes 10x plus 20 equal 21. Subtract 20 from both sides. 1 will equal 10x. And if I divide both sides by 10, I'll get x to be 1 over 10. And that would be my final answer. The next set of problems. Keep in mind, any numbers over 1, you can even think of 0 as being a number over 1. That saves you some pain on the long run. So, I see a fraction, I should be thinking right away of LCD. What's the LCD? The least common denominator for this problem is 21. And the goal is to make sure that every term is over 21. You notice here I can't reduce the 3 and the 7. So, what do you multiply 1 with to make it a 21? 21, remember, whatever I multiply the bottom with, I multiply the top with. I want to make it a ratio of 1. What do you multiply 3 with to make it 21? A 7. Whatever you multiply the bottom with, you multiply the top with, a ratio of 1. And what do you multiply a 7 with to make it 21? A 3. Whatever you multiply the bottom with, you multiply the top with, a ratio of 1. They all have a 21 in the denominator. You ignore that. 21 times 5, that's 105. Negative x times 7 is minus 7x. And 3 times 3 is 9 into x plus 1. Get rid of parentheses. I suggest you don't skip any steps until you get the hang of this. Then you could start skipping a lot of steps. So distributing the 9 in, that's what I get. And now, the same as before, I'm going to move the smaller variable to the larger variable. Add 7x to both sides. That's 16x plus 9 equal 105. Subtract 9 from both sides. If I take 105 minus 9, that will be 96. Divide both sides by 16. And x would equal, let's see how that works. Would that be an... let me see. If I take 96 divided by 16, I could reduce the top by 4. Let me see. So I could say, I could reduce each, or I could say, you know what, 1 divides 9, 9 times, that's too big. 8 times, that's 100 and some, that's too big. I could try for a 7. 7 times 6 is 42, so 112, that's too big. So, you know, however you divide, I could go for 6. 6 times 6 is 36, carry the 3. 6, 96, it works out evenly. So the answer is 6 for this problem. And that's how we do all the problems in math. We really want to get this out of the way. Again, I'm looking at this problem and I'm thinking, well, the LCD here is... Now, if you have two fractions equal, you could cross multiply as well. Or you could say the LCD is 3x minus 7. It's better to really do it this way. I know it looks like we're doing things the long way, but on the long run, this is going to benefit us a lot. And a 3x plus 1. So what is this missing to have the whole LCD? A 3x plus 1. Whatever you multiply the bottom with, you multiply the top with. And this is missing a 3x minus 7. Multiply by 3x minus 7, top and bottom. I want this to look better. We have plenty of room, no need to squish things in. Here we go. So the LCD was, and we multiply, this is missing the 3x minus 7. And now that those have the same denominator, you just ignore it. This problem just became 5 into 3x plus 1 equal 3 into 3x minus 7. There's a small catch. Your answer cannot make the LCD equal 0 because you're not allowed to multiply by 0. Get rid of parentheses. That's 15x plus 5. That is a 9x minus 21. Move the smaller to the larger. If you subtract 9x from both sides, 15 minus 9 is 6x. Move the 5 over. Subtract 5 from both sides. That's negative 26. And if I divide by 6, I'll get x to equal negative 26 over 6. If I reduce by 2, that's 13 over 3. And that would be my final answer for this problem. And since that doesn't make this or that a 0, that's an acceptable answer and that problem is complete. If I get to number 14, keep in mind this is over 1. My LCD for this problem is simply, oh, I messed up. I didn't see the negative right there. That should have been a negative 5. So that's going to change a few things. Okay, I'll go back quickly and fix it. If I was to multiply by a negative 5, that's negative 15x, and that's a minus 5. And if I was to move the smaller to the larger, add 15x to both sides. 9 plus 15 is 24x. Add 21 to both sides. That will be 16 equal 24x. Divide by 24. X would be 16 over 24. If I divide the top by 8, that's a 2. And if I divide the bottom by an 8, that's a 3. Sorry about that. There it is. I'd like you to solve the problems the same way I'm solving them, moving downwards. If I look at number 14 now, the LCD is x minus 4. This is already there. This is already there. This is the only piece I need to multiply by x minus 4. Whatever I multiply the bottom with, I multiply the top with, a ratio of 1. since they all have the denominator the same LCD, I just read the top. This reads negative x plus 9 into x minus 4 equals 6x. Get rid of parentheses, distribute the 9n, 9x, negative 36. Combine like terms, that's 8x minus 36 equals 6x. If I move the smaller variable to the larger, so that is subtract 6x from both sides. Now reverse order operations, move the 36 to the right, that becomes a positive 36. Divide by 2. 36 divided by 2 is 18. That would be my final answer. It's an acceptable answer because it does not make the LCD equal 0. 4 is the only value that makes the LCD equal 0.